Hey, how you doing? My name's Elton. Welcome to Learn Docker in a Month of Lunches. This is episode 14 of the series, and today we've got a really cool topic. We're talking about configuring your Docker engine for remote access so that from one machine you can connect and control containers on another machine. And that's really the enabler for the deployment part of your CI/CD pipeline. So imagine your build job. We covered continuous integration in a previous episode, but we only really got as far as building your application inside containers using multi-stage Docker files, and then pushing to a local registry. And we kind of finished there. The next stage is deploying it to your test environment and then onto your production environment. And for that, the machine that's running your build server, your build job, whether that's a GitHub action or Jenkins in a container or whatever, needs to be able to access that remote container and access it securely so it can connect and deploy your latest version of the software. And that's what we're going to cover today. So let's get on with it. So here we go. Let's look at the slides. So if you're new to the series, like it's always the same layout. I spend a few minutes going through the website for the book and doing a bit of self promotion. Then most of the work today is on chapter 15 of the book, which is configuring Docker for secure remote access and CI/CD. We're going to be using both the local Docker environment. So I've got Docker Desktop on my Windows machine, but also we're going to be using Play with Docker, which is the online Docker playground. We looked at that a bit in the previous episode. We're going to use that as our remote machine, and we're going to run a local job to deploy to our remote production environment, which is Play with Docker. So there's some good stuff coming today. And last of all, of course, Q&A. Any questions, put them in the YouTube chat window or put them in the DIAMOL Slack channel, which is I'll show you the link to that in a second. And I usually go on for sort of 50-ish minutes, even more like an hour mostly at the moment. And if there's time at the end, and there's good questions, then we'll have a little bit of a discussion at the end. Okay, cool. So let's get on with it. So first of all, we're going to go to the website. So this is diamol.net, Docker in a Month of Lunches. And all this is like the homepage for the book. So this series is effectively a YouTube serialization of the book, and the whole premise of the book is you can learn Docker like in small chunks, an hour a day, like normally in your lunch break. And each chapter is really tightly focused on a particular topic. It's really task heavy, so it gets you to run lots of exercises, get lots of experience in using Docker and working with the principles as well and the practices. So there's a whole bunch of stuff in there. You can buy it from Amazon or Manning with the links here. If you don't want to buy it, that's totally cool. All the stuff is on GitHub. So all the Docker files, the compose files, all the source code for the demo apps that I use is all on GitHub, and you can just kind of play around, clone that, have a play with it, see what works for you. I've got my Slack channel. If you've got any questions you want to ask me directly, the stream link will always take you to the most recent stream, and the giveaway. I've usually got a few copies to give away, digital copies of the book, so you might win yourself a copy. And if you're done with Docker, the next step is Kubernetes. Your lunches might need to be a bit longer than an hour for that book, but you will learn an awful lot about Kubernetes from that book, which is the sequel to this one. Okay, there's a bit of stuff in there. Here are all the links to all the previous episodes. So today we're on configuring Docker for secure remote access. We've been talking about container orchestration. Actually, we're not doing much orchestration today. The idea being that whatever you remote machine you're connecting to, you can run the same commands that you run locally. So we're just going to do kind of Docker container run commands to make our life simple. But you can imagine in your build process, as soon as your manager is enabled for secure remote access, you can do your Docker stack deploy. So we're just going to keep it nice and simple today. But the ultimate goal would be your production environment can be securely accessed from your build jobs, and you can deploy directly there. That's about it. I think that's it for the videos. For the marketing piece, most of my other stuff is on Pluralsight, so you can get my Pluralsight courses there, and you can follow me on. There's my blog, and there's the rest of my YouTube channel. Okay, so let's go and get to the chapter. So chapter 15. So this is all about being able to kind of work with Docker remotely. The big enabler for that, obviously, is in this episode, continuous deployment. But of course, you can just use that for ordinary admin tasks. I can connect to my machine that's up in the cloud. So this is a super powerful thing because all you need to do is configure it nicely, and I can just switch from my local laptop to managing my 32 CPU, 100 gig of RAM machine that's running up in Azure. I'm running the same Docker commands locally, but they're getting sent across the wire to my machine in Azure, and I'm managing it remotely. So it's super cool. And it's also how it's how you can do your administration, but it's the deployment stuff that we're interested in here. There are a couple of ways that you can expose the Docker API. So quick refresher, when you send your Docker command lines, it just sends commands to the Docker API, which is an HTTP API that sits with the Docker engine. The Docker engine is the thing that runs your containers. So when you want to manage your application containers, your Docker commands are going to the API, and the API is doing your container creation or your container list or whatever it is you're asking for. That the channel between the Docker command line and the Docker API, when you're running locally, is a kind of private channel. So it's a named pipe in Windows. It's a Linux socket in Linux, so you can't really interfere with that. So it's a nice kind of safe way to be working with it. When you enable access across the network, you're enabling TCP access, so you can do that insecurely. So you've got basically a plain text HTTP. Anyone can do anything to your Docker engine. Or there's the secure option, which involves you kind of creating a bunch of certificates. And we'll go through both of those options today. Obviously, the better one is the secure option, and that's the main thing. So you can enable the Docker engine to just listen on an insecure channel. So the main ways to configure Docker, you've got your daemon.json file, which is it's the same file in Linux and Windows, and that's where you put all these things. Like we've already put the insecure registries in there to let Docker work with an HTTP registry. But here's the thing that is the default channel. So on Linux, you'd have this end pipe. So this is part of the hosts configuration inside your config file. Where is Docker listening? Where is the API listening for incoming communications? So on Linux it would be FD, and on Windows it would be end pipes. That would be your name pipes. You can also add a TCP connection, and this line here you should never have. This is saying that I'm going to listen on port 2375 for any of the IP addresses on the machine, and it's insecure. It's HTTP, so there's no authentication. Obviously, there's no audit trail of anything that happens there. So anyone who can find your machine address can manage your containers. So I'm going to show you how to do it, but like you must never do this yourself. The other way is if you've got Docker Desktop. So if I open the Docker dashboard here, the latest version of Docker Desktop, they have this really cool dashboard. As part of that, I've got my settings here. I'm going to go to Docker Engine, and I'm going to go to General. And here I've got this option here. Not all of the Docker desktops have this. So I've got the latest Windows release, and I've got this option to expose the daemon. Daemon is a Linuxy term that means the background engine, background service. So I can click that button, and it says without TLS. There's a nice little warning there that says kind of please don't do this. But I'm going to show you how to do it. So I'm going to apply and restart. If you don't have this button, which you won't have on the Mac, then go into Docker Engine, and there's your JSON file. You can do the same thing in there. You can put in your TCP connection. So this is a bad thing to do, but I've shown you how to do it now. So what I can do now that I've enabled remote access, any machine on my network, anyone who can connect to my desktop here can manage my Docker containers. So I'll show you how to do this. Open my terminal. And so the Docker command line that we've used every day on the series, hundreds of times a day that I use it myself, you can supply this host parameter, and the host says I'm using the same Docker commands as usual, but I'm passing it to a different machine. This happens to be my local machine, but of course it could be any machine. With just this parameter, it needs to be able to connect. So there are no authentication details here. There's no credentials. It's just anyone can access it. So I can run my Docker container ls. I've got no containers running right now. If I do a Docker container run, what have we got that's nice and small? Nginx Alpine. I'm in Linux container mode on my machine, so this will pull down Nginx. Super tiny. I'm not running it in the background, so this is why I usually do the copy and paste thing, so you don't have to watch me struggling my way through here. Okay, so that's got a container running now. So if I repeat that command, going through the TCP channel, then I can see those containers, the one that I exited and the one that I started detached. So it works in the same way, and of course it's just an HTTP endpoint. It's kind of mostly RESTful, but there is a streaming endpoint as well. So I can just use curl on my local host. /containers will give me the container list, and it's got this kind of not terribly RESTful way of telling it what format you want it into. So I've got /JSON, and inside here I get like an uglier version of the stuff we've just seen. I've got the command, all the details of the command of the core details of the containers are coming through here. So what command it's running, what ports are exposed, the IP address is inside the container, all that sort of stuff. So if you enable your Docker command line, your Docker engine to be remotely available without securing it, anyone can access it. So it's kind of pretty much game over if you're on a big network, because anyone can be hunting around. By convention, Docker uses port 2375. So anyone who's doing any port sniffing to see if 2375 is open, if it is, it's probably a good bet that you've got Docker unsecured. So don't do that. So this bit here, as it says, so imagine if you're in the ops team and someone comes along and says, "I want you to enable remote access for the production Docker server. So can you just do this from this chapter of this book and make it available to everyone?" Hopefully your ops team would not countenance that for a second. Luckily, there are better ways, and we're going to move on to that now. So the other thing is, you need to bear in mind that the Docker engine itself doesn't really have a concept of authentication. You can either access the engine or you can't. So even though we are going to show you how to use TLS certificates to secure the channel, and so you get the credentials part there, so that the user has to have the client certificate in order to be able to connect. But once they're connected, Docker doesn't know who they are. It doesn't have any audit trail of what they've done. So even when you've secured your channel, like, you only use this for specific circumstances. So as the point here, look, when you're working with a remote Docker engine, any commands that you send kind of work in the context of that machine. So if I do a Docker container run and I mount the root of the local disk, the local disk is that server's disk, so I can go and look at whatever's on the server. So obviously that's not kind of the sort of security profile that most companies want you to have. Okay, so let's go and have a look at this. So I'll do this for real now. So I'll open up my channel again. So if I do a Docker host, same as before, I'm running Linux containers. So I'm going to do Docker host. So I'm telling it to run against my local machine. I'm doing a container run, and I'm mounting the root path of my context where I'm running to the host drive folder inside this container. So I'm running interactively, so this will drop me into a shell in the container, and then I can just do an ls, and I'll see I've got this host drive path here, and I'm inside a Linux container. So then if I do an ls host drive, what I will see is the contents of the actual machine. Now I'm running with Linux containers here, so what I've actually got is the contents of the Linux machine that's hosting the Linux kernel that's hosting my containers. Otherwise, if I ran in Windows mode, I would see my C program files and all that stuff from my Windows host server. I'm using the Windows subsystem for Linux, which has actually got the Linux file system, so I can see this in here. But inside, if I look at C host drive /mount, then I will see, oh, there's nothing in there. Oh, that's cool. So this is what I kind of expected to see somewhere inside. I'd see my C drive. But anyway, so I'm inside the WSL. So that's why I see that. If I was running a kind of a standard Windows build and I was running a Windows servers, I would see all the Windows files on my C drive. So it's it's a pretty elaborate, easy way to get into things. So bear in mind that when you open your engine, you are opening it to pretty much anything. Okay, so here we go down here. So ordinarily, like if you need access to manage applications or to even manage an application server, like a web server, you don't get unfettered access to the machine. You don't get access to the drive. You don't get access to be able to go and edit files or look at files and all that sort of stuff. But with containers, you can, because this is a kind of exploit that if your ops team aren't fully aware of how containers work, somebody can do exactly that on their remote server. They can go and look at the drive, and you can get this kind of nice little thing here. If you're looking at your payroll system, it doesn't stop someone just running a container on that remote server, editing a few files, and giving themselves a nice little pay rise. Okay, so let's go and undo that. So I'm going to go back to my settings here. I'm going to go back to my general and undo that, because even though I'm in the only people on my network are the rest of my family, I still don't want to take any risks. Okay, so let's turn that down. We can go now. So let's get out of that one. So the other options are secure access. There's a couple of different ways of doing this too. You either use SSH, so the same as when you connect from a Linux machine to a remote Linux machine, the secure shell that goes over port 22, so it's secure communication. It also has the authentication part in there, because you have the user has to exist on the remote machine and have access to do it. Or you use TLS. Now, TLS is the same certificate principles that are used in HTTPS websites, so pretty solid, pretty thorough. Docker uses mutual TLS. Mutual TLS, the idea is that I've got the server certificate that identifies who the server is, and I can be sure that it is who they say they are because I trust the certificate. But with mutual TLS, the client needs a certificate too. So the client needs to present their credentials, and the server needs to trust the client. So you get that kind of two-way trust there. So those are the two options. They're both kind of cross-platform, because nowadays Windows supports Secure Shell 2. So you can use SSH or you can use TLS for either of them. They have pros and cons with things like managing the overhead of certificates versus creating users in your target servers and all that sort of thing. So something you need to kind of think about here. Okay, cool. So you're getting error. Oh yeah. So we're gonna do for the rest of this section. So we're gonna be monkeying around with some settings in Docker. Like it says here, don't try and do this in Docker Desktop. Best case scenario, you'll get an error and it won't let you make the changes. But depending on which version of Docker Desktop you've got, it might let you adjust these settings and then everything will be broken. So don't do this in Docker Desktop. I'm gonna use Play with Docker, which is the kind of web playground. But if you've got, a Raspberry Pi or a remote server lurking around, you can kind of do it on that server as well if you want to. So this is the part that I was talking about here. So let's zoom this massive diagram out. So if I'm doing my Docker container run commands, I've got three options to gain access to that machine. I can either just do the HTTP, which is what we've just talked about. So make that port 2375 convention available unsecure. Anyone who's got access to the machine can run either run to the API directly or can use the Docker command line to manage containers. Mutual TLS requires certificates, so you have to have a certificate on your server and a certificate on the client to be able to make the connection and run the commands. And then SSH is also encrypted, and it kind of works using the same SSH logon mechanism. So you have to exist as a user in the remote machine, and then you log on either using your SSH certificate or with a password. So you kind of that works in that usual way. Okay, so I'm going to do what I did yesterday. I'm going to drag this out of the way because otherwise I won't be able to see what's going on because the Play with Docker interface takes up the whole screen. What you can see now is Play with Docker. Simple online playground. It's really easy to use. When you click Start, if you haven't logged in, you'll be asked to log in with your Docker Hub user account. You can add as many instances as you like, I think up to 5 or something like that. And they're kind of like virtual machines with Docker installed. And you just use them. You just use them as you would use a virtual machine. So let's clear this down. Unfortunately, I can't shrink this down. So the UI kind of doesn't let you monkey around with it too much. So that's why I've shifted everything over to the other side. But all the exercises I'm going through, they're all just copying and pasting from the book, from the chapter. So you'll be able to do this yourself. Okay, so what I'm going to do is I'm going to get I'm going to set up this remote Play with Docker session, which is just a temporary session that I've got access to until this session ends. I'm going to make this engine remotely available so I can control it from my desktop down here. I'm going to do it securely, so I'm going to use TLS certificates. But rather than go through all the kind of generating the certificate and passing all the details and putting it in the right place, all that sort of stuff, I've wrapped up all that inside a Docker image. So there's an image here called PWD TLS, which is going to do that for me. So what I'm doing is I'm going to run a container. And this is why running a container can be kind of dangerous when you allow volume mount. So I'm mounting a volume on the drive here that I've just created, the path that I've just created called DIAMOL certs. So that's where the certificates are going to live. They're going to live inside /certs inside the container. But I'm also mounting the path where my Docker configuration file is inside Play with Docker into the container. And this container is going to do a couple of things. It's going to create these certificates and copy them onto the host. And then it's also going to edit the configuration file on the host. So this container is going to change the way that Docker itself is configured to run. That's why you don't do it on your Docker desktop machine. Okay, so it's going to pull that down. It's all kind of super tiny container images, so it should happen pretty fast. What it does is it's going to put those certificate files in there. So if I go and look at what is it, DIAMOL certs, I call it that. So it puts in a certificate authority file, the server certificate, and a server key. So it gives me the server side of the TLS, the mutual TLS exchange. If I clear this down as well, if I go and look at it's the daemon JSON file, so it's in etc docker daemon.json. Then this is what it puts in here. So it puts in this TLS true, it puts in the path to the TLS certs, and it adds this host. So it adds the TCP. Let's not secure that. Let's not highlight that. It adds this TCP 2376. So again, by convention, a secure Docker engine that's using TLS will listen on port 2376. And these other parts of the configuration, that tells the Docker engine that it's secure. It's going to be using TLS. Here's where you find the CA certificate. Here's where you find the server key. Here's where you find the server certificate. So all that means now I've got a secure encrypted channel to be able to communicate to my Docker engine, but I can't use it unless I've got the client certificate. Okay, if you make any change to the Docker configuration, you have to restart the Docker engine. So I'm going to do that in the way you do that in Play with Docker is this kind of funky way of killing the Docker daemon. So that's Docker D, and then you start another Docker daemon in the background. So let's do this. So this is not something you would normally do. Like on a normal server, you edit your daemon JSON file, and then you do a service restart Docker or however you're starting your service. This is just to get around the fact that Play with Docker has all these kind of super clever optimizations because each of these sessions is running inside a container, and it all just gets kind of confusing. So Docker inside Docker, this is how you need to do this stuff. Okay, so the last thing I need to do, I need to enable the port. So I'm going to do this bit here. Where are we going down here? So I'm looking at my other monitor, which has got the final instruction. So I need to open a port. So you can run containers inside Play with Docker, and if you publish a port, then you can access them from remotely. So I can open port 2376. And what it's going to do is it's going to give me a domain name here. So this big ugly domain name is unique to my session. So this will only survive as long as I'm using it. And as soon as I close my session, it'll be gone, and it won't be usable for anyone else. So I'm going to take a copy of that in my clipboard, and then I'm going to go back to the chapter. So let's drag this over here. So these are all the things that I've been doing. So those are the commands that I ran in my Play with Docker session. This is the output that I got, and here's me opening port 2376. And if you want to see how I generated those certs and how it does all that stuff, that's all inside that cert generator folder. It just runs OpenSSH, which is the tool you use to generate certificates. They're self-signed certs, so they're not something you can use to if you host a website using a similar mechanism, then you'll get a warning when you try and browse to it because it's not a recognized certificate authority. But it's fine for local communication within your own network. Okay, so I've opened up my TLS port. This is the configuration that it edited, so that's why you don't do it on your own machine. You make sure you know what it's actually going to be editing. And now my engine's good, and now I can connect to it remotely, and it will only allow me to do it if I've got a matching client certificate. And this little diagram here is showing you kind of how the relationship between the server certificate and the client certificate. When you generate a certificate with OpenSSH, you give it the name of the certificate authority, which kind of guarantees that particular certificate. And both the server cert, which the engine is using to secure its part of the channel, and the client cert, which the client will present when it tries to connect, they both use the same certificate authority. And you can have any number of client certificates as long as they all use the same certificate authority. And similarly, as long as you can have any number of server certificates, as long as they all use the same certificate authority, then you have that authentication chain. So as long as I'm using a client cert with the same CA as the server cert, then I can go and communicate with it. Okay, so now I've got my PWD domain. So let's go and put this inside a variable. So flood CLS. So I'm going to do $PWD domain. No, $PWD domain. It's just the way I store a variable. This is slightly different for Linux, and that's in the next line. And this is my domain here. Don't include the HTTP bit at the beginning. So you just want the domain name, which is this kind of lengthy thing that Play with Docker generates for you. So that's the bit that I'm storing. So this is the example here. So that's what it'll look something like that without the HTTP bit. And then in Linux, do the same thing, but without the dollar. And now if I try, from now on, the commands are the same for Linux and Windows. If I use curl to try and get to my PWD domain and list out the containers, I could do this locally when I enabled my insecure channel. If I try and do this, I get this error. Client sent an HTTP request to an HTTPS server. So it's saying you can't do this because you should be using HTTPS. If I try and do it with the Docker command line, same deal. I'm using the -- host parameter, and I'm using the domain name of my Play with Docker session. I'm doing container ls. I get the same thing. Client sent an HTTP request from, and it should be HTTPS. Now, the way I need to work this now is I need to have those client certificates, that client certificate from the same certificate authority, and pass that as part of my Docker command so that I can authenticate and the server knows that I'm allowed to run commands. So this is not how you should distribute certificates. So certificates are kind of privileged information. So putting them inside your GitHub repo for your book is you would only do that for a simple demo. But in the GitHub repo for the book, there is a zip file with the client certificate in there. It's not how you do certificates in the real world. Ordinarily, you have a secure way of you generate a client cert for each person you want to have access to, and you would distribute it securely in some way. But here I am doing a book, so it's just up in GitHub. I'm in the wrong folder here. So I've already created this temporary folder. I'm in with this directory here, and I'm going to do the tar command again. So all these commands like curl and tar, if you're a Windows user, the latest versions of Windows 10 have all those commands, so you can use all this stuff just exactly as it is in the book. And I'm extracting these files from this zip file, and that's it. I've got my CA certificate, I've got the client certificate, and the client key, so that I can do my part of the TLS, the mutual exchange. Okay, so I've got everything I need here, and now I can, with this huge, big, ugly command line here, it's just still the same host command. So I'm passing to a different host, but I've got effectively a similar set of flags to match what is inside the Docker daemon JSON. So as well as specifying the host, which is my remote server, oh, I don't know what I've typed there. Let's undo that. Which is the remote server. I'm also saying that this is a TLS communication, so it needs to be verified. Here's my CA cert, here's my client cert, and here's my client key. So I'm presenting all my side of the TLS exchange. And now it works. I don't have any containers running, so I get this empty list, but this is now on my Play with Docker session. So when I'm sending all those parameters in between my Docker word and the Docker command that I'm sending, I'm controlling this remote machine, which is pretty super cool. And I can do any command. So if I do this to create a container, let's go over here. So same lump of stuff to connect to that remote machine. We'll see a better way of doing that shortly. But now I'm doing a Docker container run, and I'm going to run the Apache web server. This output is coming from my remote machine. So it's the Play with Docker instance that doesn't have that image locally. It's that Play with Docker instance that's pulling it, extracting it, and we'll start running it. And it's going to publish a random port. So if I go over to Play with Docker here, let's go back here. If I now do a Docker PS on here, which is just a shortcut for Docker container list, there's my Apache that was started 11 seconds ago from my remote machine. So I can manage it. I can do whatever I want to do, but now it's securely connected, so no one can access that without the client certs. Except obviously, if you're watching this, you can, because you can get your own client certs. If you're watching it live, you can do whatever you want to my machine because you've got all the details now. So bear that in mind when it comes to sharing client certs. But this is how this is the kind of basis of doing the management here. The ugly part is I've got all these parameters that I need to pass around, and it's just like a recipe for a problem coming down the line. So what Docker has is this. There are two ways you can deal with that. The SSH part is really simple. So instead of doing the TLS part, I can secure with SSH. If I'm in an all Linux environment and I already have like the SSH infrastructure, so I have people generating I give people SSH certificates to connect to the machines. I set users up with a whole bunch of credentials, all that sort of stuff. If I've already got that, then it makes sense to bring that into my Docker world as well. Now I've already got that in my Play with Docker session because it sets up all that stuff for me. So if I had a new instance here, and again I've dragged my instructions over to the other side, but everything that I'm doing is in the book. I've had a new instance in between node 1 and node 2. All the kind of SSH stuff is already set up. So if I'm in my node 2 session, and what I'm going to do is grab the IP address of the node 1 node, which is, let's do node 1 IP is 192.168.0.18. Okay, so that's my IP address of the other node. So this is like two VMs effectively that are both running Docker, and I can just check that I can SSH into that machine as root, and check that this is authenticated. Yes. So all the certs and stuff is all set up for me in my Play with Docker session. So I can add all these nodes and they can all talk to each other and manage each other. So if I exit that, that's all good. So I've got everything I need to be able to remotely manage that machine. If I show my containers that are on this node, so node 2, which is brand new, shouldn't have any containers. So there's nothing on there, which is expected. And if I go and clear this down and now look at the containers that are on node 1. So the syntax here, it's still the -h parameter, which is just a short form of --host. And I'm using SSH instead of TLS. And then it's whatever you would use in your SSH command. So it's the username at IP address or the domain name of the machine. Excuse me. So by connecting to that with SSH, I get the list out of whatever's running inside my other machine. Excuse me, which is my node 1 machine. So I can manage that remotely without TLS certs, without having to do anything special. I can just use SSH directly to get onto that node. Super simple compared to the TLS thing, but it means you have to have your SSH infrastructure in place. If you already have, that's great. You just kind of use that. Okay, so that's how that looks. let's go back here so we can see what I'm looking at. So play with Docker makes it super simple, but if you've already got this yourself, then it'll be just as simple for you. Other than the fact that SSH is gonna, in order to have SSH working, you're gonna need to create users on the machine. So if I ask for permission to get to the UAT machine to run Docker commands, someone's going to create me as an Elton user and give me a certificate and set up a bunch of permissions, including permission to use the Docker socket, the Docker engine on that remote machine. So there's a kind of security thing that there's a security issue around any access, remote access to your Docker engine. So there isn't a perfect way to get this done. But bear in mind that someone who has access to your Docker server, because they can over SSH, can also SSH into your machine and do whatever you've set them up with permissions to do, which may or may not be what you want. Okay, so that's what I did there. And again, if you're primarily Windows, you can install OpenSSH Server. There's a PowerShell command that just sets it up as part of your Windows Server install, and you can do exactly the same things. You're going to be less familiar with that because we don't tend to use SSH so much in the Windows world, but you can do the same thing. Okay, so the other big thing, which I've already said, is that it gives you securing access to your engine, whichever mechanism you use, gives you encryption, so no one can overhear your conversation and intercept it, and it gives you authentication, so users have to either exist as an SSH user or they have to have a client cert that's generated by the same certificate authority. But that's it. It doesn't have any authorization and there's no auditing. So if you have access to the engine, you have access to the engine. There's nothing that stops you deleting volumes or spinning up Bitcoin miners or anything like that. There's no authorization level. Everyone's an admin effectively, and there's no auditing to say that this happened with this user. So this is something you do sparingly. But in the real world, hopefully, you wouldn't give this to other people because this would all be automated. So this is what we'll come to in the second half of the session. But first of all, we're going to look at that easier way of making this remote connection to my remote machine. So we talked about this. We did this we passed the host flag, we passed all the TLS flags, we said where all the certificates are. You have to do that every time if you want to connect to a remote machine, and that gets kind of clunky. And in the old days, people had a script. I used to have a whole bunch of scripts that set up environment variables. So the Docker host environment variable, the location of the certificates, you can put all that in environment variables. And then you can just use the Docker command, and it will pick up the details from the environment variable. But last year, Docker added this concept of a context, which is a Docker server, and you can switch between contexts, and it makes it really super easy to look at the machines you've got access to and to work with remote machines. So the way you do that is you do a Docker context create. So what I'm doing here, I'm going to create a context for my remote play with Docker session. So Docker context create PW. Actually, I've already created this because I did these earlier. So I'm going to do a Docker context RM. So I'm going to delete my old one. Otherwise, things will get a bit confusing. So I'm creating a context called PWD TLS. Call it whatever you like. It's my play with Docker session that's TLS encrypted. It's Docker because I can also use context to switch between Kubernetes clusters. And here's all the bits that I put into my Docker command. So there's the host with the domain name. There's the location of the CA and all the cert and all the client certs. So by creating that context, I've now got a nice way to switch between things. So again, if it was SSH, there's an alternative way of doing it, which is super simple. You just do a Docker context create, and you with the inside the quote marks, you put the host as your SSH with your user and your server. So super simple. If I want to see my context here, I'm going to have I think I've got a few running here. So let me expand this. So Docker context ls. So here is my PWD TLS. That's my my play with Docker session. I've also got a local machine here, and I've also got the default is my local pipe. So that's my Unix socket when I'm running in Linux container mode. I've got a couple of other remote machines here, and I've got a Kubernetes cluster that's running up in Azure. So that's everything. I've already got those other contexts, but the one I've just created is the PWD one, the play with Docker one. Okay, so I've got my default context. That's pointing to my local machine. I can switch between contexts just using that context command. So there's two ways I can do that. I can do a Docker context use, which sets my Docker context to be a different one permanently across all my sessions. So if I did a Docker context use now, then it would switch to be, my play with Docker session. And if I open up another terminal, or if I come back tomorrow and open a terminal, it's still pointing to my play with Docker session. So it's good, but it's slightly dangerous because you don't know what context you're using. The alternative is to use is to use an environment variable. So instead of setting my context with Docker context use, I'm setting an environment variable called Docker context, just with the name of the context that I'm using. And now when I run Docker context ls, I will see the asterisk tells me the one that's currently selected. So even though I haven't done any Docker context commands to switch between one or the other, it uses the environment variable value. So my play with Docker is the current context. Now if I do let's come back here. If I do a Docker container list, I should see my Apache container running up on play with Docker. So that's my play with Docker session, just to kind of prove that's working. That's the port, the random port that's published. If I open that on play with Docker, it's going to browse to it. And that was great, wasn't it? That was good. So it should have gone to that port, but it could very well be that my command didn't work properly. Let's have a look at this. Oh yeah, it's still going. Okay. So I don't know, some sort of network glitch there. I shouldn't have done that. That's not in the book. So I should stick to the script. Okay. Now, if I do a Docker used default, you may think this is going to put me back to my default because that's what I'm telling Docker to do. So I'm doing Docker context use default. And now if I look at the containers again, I should see my Nginx container, which is running locally, but I don't. I'm still connected to play with Docker. So I'm still seeing the play with Docker container. It's very confusing. The Docker context that you set is overridden by whatever is in your environment variable. So even though my Docker context is set to be default, which should be my local machine, default actually means, let's do a Docker context ls again. Default actually means use the environment variable. So that's why it's still set to be this. So my default is my local Docker engine, but that's not selected because the environment variable overrides it. So it gets a bit like this is why you should use the environment variable so that when your session ends, you always go back to the default context. Otherwise, you do a whole bunch of stuff on the production server, and then the next day by accident you go and wipe out a load of containers because you think you're still connected to the local context. Okay, which then brings us to the point of that really should you be going to the production server and doing anything anyway? Ideally not, because everything should be automated. And that's where we come into our CI/CD pipeline. So let me clear this down, and I'm gonna reset my environment variable so I don't get confused. So now when I put my environment, I can either delete the environment variable or I can set it back to default. And now when I do a container ls, I'll see my Nginx container and all the other stuff that I started. Okay, cool. So now I'm back to pointing to my local machine. So the Docker context stuff is really good, but bear in mind that stuff about the context switch is permanent. The environment variable overrides it, so you can think you're using one context, but actually you're using another. And so try and stick with the environment variables. So when you end your session, you start a new session, you're always using your default context. Okay, so now we are on to the real meat of the session. Or the real protein of the session, I should say. This is the continuous deployment part. So we've already done in a previous episode, we looked at spinning up your whole infrastructure stack, Jenkins and your Git server and your local registry, all that stuff in containers and running a build. It was super simple. And I'm sure some of you are watching and think, well, you would never do that. Normally, you're going to use GitHub Actions, you're going to use Azure DevOps, you're going to use whatever managed tool you are. And I'm sure you are. But, for the purposes of making this simple to follow along, you just need Docker and you can do exactly what I'm doing. So I'm not relying on you having to set up an Azure account or anything like that. We can do the same here. We're going to do the same in this episode. We're going to spin up similar infrastructure, those three components, but this time we're going to configure our Jenkins build so that when it's done the build and it's done the little test of the container the container image that it's built, it's going to push to my remote Play with Docker session. So the Play with Docker session that I've set up is using those certificates, is using TLS. My Jenkins server, which is running inside a container, can push to can create a container using the remote context and create it on my Play with Docker session. So I'm going to pretend that Play with Docker is my production environment. I'm going to get Jenkins to deploy to it. So sounds more impressive than the demos would think, because there's a few little things going in to make it as easy as possible for us. So it'll be super simple to do. So let me see where I am. I'm already inside here. So I'm going to go in infrastructure. This is where my Docker Compose files are. I'm using Linux containers, so I'm going to use this command here. All I'm doing is starting up all the stuff in there, and as always, the Compose files are all inside the GitHub repo. So I'm inside infrastructure here. Let's close these down. I'm using Docker Compose. So this has got all the same sorts of things you've seen before. I'm using Gogs, which is the Git server. I'm using a local registry that I'm going to push to, and then I'm using Jenkins. And the override file, we learned all about override files in the episode about Docker Compose. The override file kind of does some extra stuff with Jenkins. So what it does is it mounts a few volumes, it mounts the Docker socket, and we covered this before. So now the Jenkins container can send Docker commands and use the local Docker engine. So I don't need remote access to my local machine because Jenkins is running on that machine. I'm also mounting this scripts directory. This is how you automate your Jenkins setup. So this Jenkins image doesn't have a whole bunch of stuff in there. When the container starts, it will see all these groovy scripts inside that folder, and it runs through all those scripts, which will set up my pipeline and my client certificates and all that stuff. And then the last thing is I'm mounting that directory where the play with Docker certs are. So when this container starts, I've just automated it to make it easy to follow along, because the purpose of this episode is not about Jenkins; it's about the workflow. So when Jenkins starts, it'll be pre-configured with my certificates, my TLS certificates, so that it can become a client to talk remotely to my Play with Docker session. That's really all that's happening in there. And again, you can look at those scripts. If you're into Jenkins, like the way you automate it with Groovy is really nice. So you can kind of look at how that stuff works. Okay, so that should be up and running now. So let's see what I've got. I do a Docker PS. There's a whole bunch of stuff going on here, so that looks good. As before, I'm going to go to Gogs and set up a local copy, a local repo in my Git server, which I can push to, so I can send my code there. So I'm going to go to localhost 3000, which is my Git server. And again, we did all this in a previous episode. You can't super automate Gogs. Like, it's a nice lightweight thing. It's not that big a deal that you can't automate it, but you have to kind of go through, click on install in that first window. This is all in the previous episode. You can see this stuff. Create a new user. I'm going to call it DIAMOL. I'm going to use the password DIAMOL. And then the last thing I need to do, sign in as that user and create a repository also called DIAMOL. So those things are all like the Jenkins build expects to find a repository called DIAMOL. So that's why I do all that stuff. Okay, and now I should be able to go and look at Jenkins, which is on 8080, and see if it's finished starting up now. Yes, it is. Excellent. So if I go and look at, actually just grab the link from inside here, because this is telling me where to put it. Credentials. Okay, cool. So if I look at the credentials, I can see here I've got my global credentials. Is that what I expected to see? I haven't got my credentials there. So I was having a problem with Docker Desktop, and I didn't manage to work it out. But that Docker, I'm going to do some live debugging here. So that Docker command, that Docker compose up command should have mounted my local certificates inside that Jenkins container, but I don't think it has. So let me do a Docker PS. So you see from yesterday's episode that there was a problem with Docker Compose, and I've put in a bug for that on GitHub. This I'm not sure about. It's something to do with it's not finding my local file. So if I want to find out what's happened here, this is the container ID, or actually I can just use the container name. So infrastructure Jenkins 1. What I'm going to do is I'm going to do a Docker container exec. So this runs a command inside a container. I'm going to connect interactively. I'm going to connect to that container. I'm going to run a shell. And what I'm going to do is I'm just going to see what's inside the folder there to make sure it's not a problem with my scripts, and it's not. So for whatever reason, I think it's because I've got multiple drives on my machine. So when I mount that from slash on my Windows machine, I think it doesn't know whether it should be the C drive or the D drive. So what I'm going to do is I'm going to come out of here. I'm going to kill all my containers. That's my alias to wipe out my containers. I'm going to switch to a Wsl session. So if you're not familiar with this stuff, like, you can blank out for the next 30 seconds. WSL is the Windows subsystem for Linux. It's how you can run a Linux kernel inside your Windows 10 machine. And that's what Docker uses to make a super efficient way to run Linux containers. What I've got in my WSL session here is I'm still on my D drive on my machine. I've still got access to everything that's here. If I do see where I am, I'm inside the mount on my D drive. This is the repo that I'm looking at, but I can look at it through Linux as well. And it just so happens that because I had this problem earlier, if I look at /temp/cert, is that what I call it? PWD certs. I've already got those certs ready, so I'm going to run the same command, but now it can find those. It can find those certificates. So I don't know why that happens. I should have checked that before I went and did all the GOG stuff. But something I need to look into after the session. Okay, it could be that if you don't have like millions of disks and stuff like I do, that you won't have this issue. So same thing, Docker Compose up. This is my WSL session. This is a Linux session inside my Windows session. It's connected to the same Docker engine. So if my local Docker engine, because the name pipe stuff is kind of Docker takes care of that. So on my local machine inside WSL, I see Jenkins registry and GOGs. And if I switch back to my Windows PowerShell session and do a Docker PS, I see them all again. So the only reason I'm doing that is because the certs weren't loaded from the volume. I don't know why that is. I will follow that up and I will see what's going on. Okay, so now I need to go back to GOGS because on the same port, it's now going to be an empty GOGS instance, which I've lost there. So let's go back, port 3000. So I get the install page again. So this is going to be exciting for you. I'm going to click on that. I'm going to create a new account. I'm going to call it DIAMOL. I'm going to give it a fake email address. I'm going to use the password DIAMOL. Oh, let's not do that. Password DIAMOL, retype, create new account, sign in as DIAMOL, password DIAMOL, sign in, new repository, DIAMOL. There we go. Excellent. Okay, so that's good. So now if I look at Jenkins, it's probably still starting up. Yeah, it's going to start up now. So this is what you'll get if you're a bit faster than me. When I first started Jenkins, I did a whole spiel about what was going on, and that gave Jenkins time to start. But this time I haven't, so it's going to start up now. What it's doing is it's executing all those scripts that are in that folder. So it's creating the job to build my my application and deploy it. It's creating the credentials, it's creating the default admin user, all that sort of stuff. While that's happening, Jenkins doesn't let you connect. It's in the process of it installs a bunch of plugins as well. So it does a whole bunch of stuff when it starts. It doesn't let you connect because it's not ready yet. It'll let me connect in a second. So let's come back here and see what we're doing next. Let's close that down. Okay, so that was an unfortunate interlude. But what I've got now is when I go and browse to my Jenkins and look at the credentials, I should see something similar to this screenshot, which is telling me that the client cert, the CA, and the client key, they are all loaded inside Jenkins. So Jenkins has this way of, it understands that it needs credentials to connect to remote things, and it lets you store those credential files as certificate PEM files. And I can use those inside my Jenkins files. So inside my build, it's going to say, I want to run a Docker command as part of this build, and these are the credentials I want to use. And then Jenkins securely provides them to that part of the job, so they get moved around within Jenkins. But they're not available outside of Jenkins. So it's going to use that same mechanism that I used with the host parameter and the TLS parameters to connect to my remote machine, which I'm calling my UAT environment and my prod environment. But really, it's just play with Docker. Okay, it's up and running now. Excellent. So this is what it should have happened the first time round. So those certs, they've been mounted from a local volume on my machine, or in this case, my WSL distro. And then when Jenkins starts, it uses them to install them as certificates. So now it can do what it needs to do. Okay, cool. So there's one other thing I need to do before I can do this. Let's do this here. Oh yeah, we need to look at our Jenkins server, our Jenkins file definition. Sorry, if I have a look at my environment file. So the Jenkins file is all set up for you. So all the build steps are in there, but of course it doesn't know where your domain name is, where you're putting your play with Docker domain. So here we are. Here's my domain name. So that needs to be put inside the Jenkins file. So this bit here is just telling you to do that. So let's close the browser. Open the browser. Inside here, I've got a Jenkins file. This is the job that's going to be executed. So Jenkins is already configured to have this job and run this job. It's going to do very similar to what I talked about in the continuous integration episode. There's that verify step that just prints out all the versions of the tools. There's a build, there's a test, there's a push now to the local registry. And there's the UAT steps, which are going to use these credentials that I talked about. So there's still a script in there that just runs some Docker commands, but it's using these credentials to provide access to the remote environment, and the same for the production thing. So all I need to do is in these environment variables, change my PWD domain for my actual PWD domain. Let's take out that weird space that's gone in there. And there we go. And I leave the 80. Okay. So really it's port 2376. Oh, let's not do that. Really, it's port 2376, but just because of the way Play with Docker works, like you can't necessarily access everything on any random port on the internet. So it uses it puts the port inside the domain name, and it really uses port 80. So that's all you need to do. So that is now telling the Jenkins build to go and push to my remote server, and it's got all the credentials it needs to be able to do that, to be able to create containers. So now I can do this. I think I've already done this as well. So let's just check. So I'm adding my remote. So my remote channel 15, that's good. Chapter 15. I'm going to add my domain names. And I'm going to push to my local Git server. So the Jenkins build is going to fetch from my local Git server. So you can put whatever you want in your local Git server. The Jenkins build will fetch from that. It'll do all the build steps. And then it will push to the local registry. And then it's going to go and do my deployment to my UAT environment, which is really Play with Docker. And then we're going to see the continuous deployment stuff in action. So it's actually going to go and deploy to my remote server. So back to Jenkins now. Feels like I'm going over time, but I'm sure everything will be fine. I need to log in. Do I need to log in? Yeah, I need to log in to kick off a build. Username is DIAMOL. Password is DIAMOL. Okay, and here's my build that is coming from that Jenkins file that's already in there. So as part of the setup, as part of those Groovy scripts, it created this build. It pointed it to the Jenkins file. The original build failed because we're not connected to the Git server when it started up, but now everything's going through that Jenkins file that we've just looked at. Don't worry if you're not familiar with Jenkins. It's the principles that we're trying to get across here. It's the pipeline. So these stages of the pipeline are going to be the same no matter where you run this stuff. So it's going to go and get the code from Git. That verify step to print out all the versions of your tools. That's a really useful thing to put everywhere. For some reason, my Jenkins the overlays aren't right, but it just prints out all the versions, which is super good because you can track back and see if there's potentially any errors. The test, the build and the test, the build, multi-stage Docker file, test, run some containers to make sure everything's up and running. The push is pushing it to my local registry, and the UAT stage here is running my container in my UAT environment, which is play with Docker. So if I go and look at the logs here, I just want to switch to look at the full log view because this overlay is just bizarre. Let me go and look at my console logs here. Console output. So we're doing this deploy to UAT. This is the output from deploying to UAT. So I can see it's pulling this image and it's starting my new container. And we are now in the stage where it's kind of awaiting approval. As you see there, it's awaiting approval. So go back to play with Docker. Actually, that's my thing here will tell me what I need to do to make sure that I'm not just randomly typing commands and making lots of spelling mistakes. So if I go to Docker container ls, back to play with Docker, it's node 1. Node 1 is the machine that I've got remote access to. So let's paste my Docker container ls command, and I will see I have got this time check UAT. So the time check app just runs and writes a log every few seconds. But I've deployed to my UAT environment from my local container using my Jenkins file, connecting to my remote secured engine, which happens to be played with Docker, but could be any Docker engine. Could be Docker Swarm, as long as you make the manager API available over a secure channel. Then inside your Jenkins file, you're just going to do a Docker stack deploy. Exactly the same principle. Okay, so that's super cool. Now, if you don't like the idea of continuous deployment, and a lot of traditional organizations don't, the idea that someone checks in some code and then it goes live, just you're completely reliant on all your tests being accurate and testing that everything's okay. And obviously, historically, organizations they'll have lots of memory of tests that have failed and things that looked okay but weren't. So people might be dubious about going fully continuous. But you can always do like my continuous deployment to a pre-pod environment, to a UAT environment, whatever you need to do to get that manual approval stage, to get eyes on it to make sure everything's okay. And then inside my script here, my Jenkins file, I've got an approval stage, and this is just going to sit and wait. And so I can do whatever I need to do, and my job will sit there. And as soon as I say, yeah, everything's okay, this is my audit trail that whoever's got access to this job could go and click the button to deploy to production, and that will kick off the final stage. So the continuous deployment doesn't necessarily mean that you are deploying every time someone pushes a change. You can have these approval gates in there. Sends a Slack notification to someone. Please go and check out this build in a temporary environment that you can go and look at. And then once they've approved it, then the deployment carries on. It's automated all the way through, but you can have these manual gates, and that's fine. Like ultimately, you want to get rid of it if you can, because if you can replace that manual gate with a high quality test, then you don't get the lag. You're waiting for a human to go and click a button. But if you can do it, if you can't get that point straight away, then it's fine to have this. You click this button, and then it's going to trigger the rest of the job, and that goes on to production, and that's going to do the same thing. It happens to be pointing to the same play with Docker instance, but it could be a completely different Docker engine or Docker Swarm. And now if I go back to my play with Docker and clear this down and do another list, now I've got my prod environment that was kicked off 3 minutes ago, and then as a result of me doing my manual check, I've now got my UAT environment is the older one, and the prod environment that happened after the approval stage. So you can see the kind of whole end to end there. All the bits you need to look into, they're all inside the GitHub repo. All the exercises, all the steps to do this yourself, they're all in the chapter. So you can follow this through. Make sure you're really understanding what the different parts are. And the ability to just run these things in containers and play around means you don't need to wait for a build to kick off in some remote engine. You can just do it in your local Jenkins instance. Okay, so I can see my both deployments are running. This is the part that I've already done. How am I doing for time? We are getting near to the end. Okay, so here we go. And so just another reminder here about there's one other thing to remember. And then, so even if it's available remotely, the whole thing is available. So you need to understand the access model. That I guess this would qualify as a joke. So this doesn't really need a whole section because the access model for Docker, there really isn't one. So you either have access or you don't. Things are different in like the enterprise version of Docker because there is a whole role-based access control thing. Things are different in Kubernetes. Again, they have a role-based access control thing, and you can layer authorization on top of access to the APIs themselves. But you don't get that for free in the ordinary Docker engine. So this is where you need to think about who has access to do this stuff, who has access to the client certificates that you're allowing to go and connect, who knows where the machines are and who can do that stuff. Okay. The other thing that is interesting, and so this is still emerging, but it's getting a lot of traction, is instead of having pushing out from a build server, you use this GitOps approach where the CI/CD pipeline kind of goes inside out, and the cluster itself, instead of a remote service that's pushing changes to the cluster is looking at source code to see if there are any changes, and the cluster itself will say, there's a new version of the application. I'm going to apply it to myself. So nothing else needs access to the cluster. The cluster controls it from within, which is a bit of a scary concept for a lot of people. But when I wrote this chapter, that was a really new approach. But since then, it's got a lot of traction in the CNCF, in the Cloud Native Computing Foundation, which is the foundation that looks after Kubernetes and Prometheus. There's a couple of CNCF projects now that are GitOps projects, and they're simplifying a lot of the smoothing out a lot of the kind of rough edges around there. So this is something that maybe you're going to get to one day. But bear in mind this is potentially a more secure way of managing your deployments. Okay, cool. So there we go. So yeah, so the other interesting thing about GitOps is it forces you to put everything into your repo. So you have a repo for your source code. You might have another repo for your infrastructure bits that do your compose files and all that sort of stuff. Everything's scripted, everything's accessed from the cluster, and the cluster controls what it deploys and when. Okay, so there's the lab here is to flesh out the registry part. So I kind of glossed over that when I did the remote deployment. As part of my pipeline, I pushed to a local registry and then I deployed to Play with Docker. Well, Play with Docker doesn't have access to my local registry, so inside the pipeline it just pulls from Docker Hub. So this kind of glossed over the fact that that you need your wherever you push your registry, whichever registry you push to, all your environments need to have access to that to be able to pull the image. And the lab kind of gets you to think about that a little bit more. Again, in the episodes, I don't go through the lab because it's meant to be a self-paced thing that you do yourself. But there is a solution up on GitHub if you want to check that out and see how that works. Okay, how are we doing? So we've got a couple of points from in the chat. So Iman says, do we need to learn Jenkins 2? You don't need to learn Jenkins 2. Jenkins is a really common tool, a really common automation server. So lots of people are familiar with it. That's why I use it in the book. It's super easy to automate, and it's super easy to say, look, here are a few screenshots. This is how you're plugging this thing together. The Jenkins file syntax, you do not need to be super familiar with how this works, but it uses this kind of declarative approach where each stage specifies something that's going to happen, and then the way I like to approach that is to split out the complexity into script files, so standard script files. So inside the repo here, I've got where am I CI. These are the things that actually get executed. So they're just Docker compose commands. That's the beauty of using Docker for your build and your deployments and your test, is that you're just running Docker commands. So all the build steps are inside my Docker file. All the bits that I need to build are inside my compose file. So I'm just running commands basically. So the Jenkins file or the GitHub action or whatever you're using is just really a structure around plugging in a bunch of Docker commands. So you shouldn't need to get too hung up about that. If you are interested in Jenkins, well, watch out. There's another advert coming in. If you go and look at my Pluralsight courses, I did a couple of courses recently about Jenkins. So using declarative Jenkins pipelines is the one that shows you if you're looking at a Jenkins file and going, I don't really get that, but it looks kind of interesting. That course, it's just a couple of hours. It will tell you in a lot more detail how all that stuff kind of pans out. But but the broader question, do I need to learn about automation? Yes, you probably do. It doesn't have to be Jenkins because you can configure Docker Hub to do builds for you. Link it to your GitHub account. Every time you push to the repo, it will build a new version of your image. But it doesn't do deployment. But GitHub Actions does that for you. So GitHub Actions is another alternative. So yeah, there are alternatives. Doesn't have to be Jenkins, but you probably want to be learning something in that space because that's at the heart of Docker is that it makes it super easy to automate everything, which just streamlines all your processes because you don't need to be waiting on humans to do stuff. Okay, and so that brings us to the end. So that was chapter 14. So I hope you found that useful. There's a lot of stuff in that chapter, but yeah, it's really about a couple of topics that it covers. There's that technical part of how you can make your Docker engine remotely accessible and how you should do it to make it secure. And then there's also, of course, there's the practices part. There's the pipeline part. What continuous deployment actually looks like. Why you don't need to be concerned about everything going all the way to production straight away because you can have those manual quality gates in there. Okay, and so the next session, episode 15, is the last one of the week. We are looking at multi-architecture images. So if you've been following along or you've been reading through the chapters and you're going, how do these commands work on Linux and Windows? And how do they work on my MacBook and on my Raspberry Pi? That's because of all the huge effort that I put in to make your lives easier. You can build Docker images for Linux and for Windows, and you can kind of group them together and say this image tag like DIAMOL/Apache. That's actually like an umbrella for several other images, which are for different architectures. And Docker will pull the right one that it runs. That's what we're covering tomorrow. If you're thinking about, oh yeah, I'm not interested in Windows, I'm not interested in ARM, you should watch anyway because if the only reason you watch it is because Amazon have got recently Amazon Web Services have spun up ARM-based virtual machines, which are like almost half the price of their Intel machines. So if you're running applications that are Java or .NET Core or anything that supports ARM, you can build them as an ARM Docker image without any code changes and potentially run them in AWS and save yourself a whole chunk of money. And so tomorrow's episode is all about multi-architecture images, showing you how you do that with Docker files and how you push them and how you share them and why they're really cool. So thank you for watching today. I hope that was useful and hope to see you in the next episode. Thanks. Bye.